home using lcd.home. Now we have used the lcd function inside different function to how that particular thing in the lcd like the temperature and if the heater or cooler is currently on or off using lcd.print function. Third project. This project is called Garden Lights Control, or in easy words, where going to light an LED based on LDR sensor. So, what is a LDR sensor? LDR is also known as light dependent resistors, are light sensitive devices most often used to indicate the presence or absence of light or to measure the light intensity. So, in this demo, we will light a LED when a LDR is exposed to darkness and vice versa. As you can see, we have created two files ldr.cpp and ldr.h. In ldr.h, we have defined two pins, E1 for the LDR sensor and 3 for garden lights. We have initialized two functions named init LDR and brightness control. In LDR.cpp, we have included the Arduino library main and that we earlier created in our first mini project and LDR.h library and completed the functions where init LDR takes garden lights that we had earlier defined and outputs it. Since LED is an output device. Second, in brightness control, we take an unsigned integer input value and read it with our predefined LDR sensor. Now we know that a light has a range of 0 to 1023 and we create a logic so when the light level decreases, the resistance of the LDR increases and turn on the garden lights. Now we have imported that library to our mega project which with has include and call the functions init LDR in out setup function and included brightness control in loop function. Let's not talk about blink yet and how the pins work. We will discuss about it when we have completed the whole project. In fourth project, we will be discussing about a cereal tank of a capacity of 3000 liters where the inlet and outlet valve is controlled by us. But the inlet valve will automatically start when the tank is below 2000 liters and it will stop when the tank is full to avoid spilling. So, how do we create it? We will create two header files called serialtank.h and serialtank.cpp. In our first project, we had also defined some values like water, volume gauge, which is connected to V3, inlet valve to V4, and outlet valve to V5. Now, we will come to our first header file, which is serialtank.h, where we will define digital input, digital sensor, and sensor analog. We will define enable and disable. We will initialize init serial tank, enable inlet, disable inlet, enable outlet, disable outlet, and an unsigned volume. In serialtank.cpp, we take two variables, one integer and one character. We create a logic for the volume tank and all the outlets here. pass it onto the main project. In the main project, we use a similar logic for the auto control of volume using the previous logic used in heater temperature meter. To stop it from overflowing, we initialize the serial tank using init serial tank and loop it using handle tank. Lastly, we end the code by writing two more lines called blink.run to run the program and timer.run to update the value in Blink app. Then we exported the code after compilation. Now you can see that I have attached an image of all the pins that I previously used in my code in my Blink cloud. I have assigned all the pins to their respective data types and I will be using them in my final project. Let's look at our project using the Blink IoT app. You can see I have connected my mobile device using the Blink IoT app, which has widgets like a terminal for notifications, a temperature gauge, a switch for cooler and heater in tab 1. In my second tab, there a gauge for volume, an inlet valve and an outlet valve. So let's go on with the project. So in the project, we have connected an Ethernet with the spare parts. Since Arduino IDE does not come with connectivity for the internet, the green screen is the CLCD. The part consisting of the fan is the cooler or heater. The strip is the LED. LDR is already written so it's obvious. Since LDR sensor can't work virtually, there is slide to represent darkness and light. So when I turn the LDR down, it means that there is light and the LED stops lighting and vice versa. In case of heat, when I turn on the heater switch, you can see that the temperature in the CLCD goes up and shows that heater is on, but it automatically closes as the temperature reaches 35 degrees Celsius and it shows in the IoT app terminal. When I turn on the cooler, the fan starts and the temperature drops. Similar thing like the temperature, and if the cooler is turned on or off is shown in the CLCD. Lastly, we have a serial tank in front of the screen. As I turn the inlet valve on, the inflow of the water starts. As we turn the valve off, the inflow is turned off. However, we can see that the inflow is stopped when the tank is full and it turns on automatically when it reaches 2000 liters. Similar thing is updated on the Blink app and the CLCD in the PixSim lab. And with this home automation system solutions based on IoT is created. Hope you enjoyed the session I did learning the project. Thank you very much and we will meet again next time.